the third chapter in the probability series, chapter 4, 5, and 6, the chapter 6 is about normal probability distribution. And the normal probability distribution is an example of continuous probability distribution, which means that the variable is something that you measure and not count. And these are the files that you need. As usual, we need the PowerPoint file, formulas are here, and the Excel file that you need to download and work on. And in addition, we have one more file here, which is normal table, and that's a PDF file. And it's a good idea to print this file and keep a printed copy of this table with you. And we will be using both the normal table as well as the Excel functions to find normal probabilities. Okay, so in this chapter, we're going to learn how to understand the characteristics of normal distribution, compute normal probabilities, and also we're going to look at ways to check whether a given data set has approximate normal distribution or not, because normal distribution is one of the fundamental distributions. We're going to be using this again and again and again in all the chapters, and oftentimes we make assumptions that the data follows normal distribution, and we should be able to verify whether that assumption is a reasonable one or not. So we're going to look at how to verify that. So it is a continuous distribution, and remember, continuous distribution is one where you make measurements, and here are some examples. We've already gone over these examples several times. And normal distribution is one where we have a distribution that looks like a bell-shaped curve. There are a couple of things that you have to note here, and that is, in continuous distributions, what you get is a shape of not probability, but simply what is called a probability density function. And therefore, probabilities in continuous distributions are measured by the area under the curve. And this is extremely important. Because in a continuous probability distribution, a particular value, a specific value, will have an area of 0, and therefore probability is 0. Okay, we can only have positive probability for a range of values. If you specify a range of values, like for example x sub 1 to x sub 2, then we can find what is the area under the curve for that range, and that area then becomes our probability. And so area for a specific value is simply a line, and the area for a line is 0, and therefore probability for a specific value is 0, and probability for a range is what we are after. So in the normal probability density function, so it's not the height of the curve does not give you the probability. Remember, it only gives you the shape of the density function. It is the area under the curve that is probability. So that PDF shape, that is probability density function, if it is bell-shaped with a specified mean and it is symmetric, bell-shaped and symmetric. So that means the mean, median, mode, they all fall at exactly the same point. And then it is a normal distribution. A normal distribution, the left side end is minus infinity and the positive side is plus infinity. So it spans the entire continuum of the number line. Okay. And sigma is the standard deviation, measures the spread. So there are two parameters for normal distribution, the mean mu and the standard deviation sigma. So we need to have these two numbers for us to be able to compute probability. If you don't have either one of them, we cannot compute normal probability values. Okay, this is the density function itself. You don't have to worry about this. This is the equation that you need to use to determine how high the probability density function is. But we are not interested in the height of the function. We are only interested in the area, so we don't have to worry about this. And here are some examples of what a probability function, normal probability function will look like. See, with mu and sigma, if you look at these two, A and B, they seem to have the same mean, but A, since it is more peaked, the standard deviation is smaller. So standard deviation for A is smaller than that of B. Now C is even much flatter, so C's standard deviation is going to be larger than both A and B, and besides the mu is also shifted to the right, so it has a greater mean mu. So normal distribution shape once again, okay, is something like this. And if you want to compute, well, there is a specific type of normal distribution. Or see, normal distributions are defined by mu and sigma. For a particular value of mu and sigma, so if mu is 0 and standard deviation sigma is 1, then that particular normal distribution has a special name, and that is standardized normal distribution or standard normal distribution. Standard normal distribution is a normal distribution that has mean of 0, standard deviation of 1. And the reason why standard normal distribution is important is any normal distribution can be converted to a standard normal distribution, and the standard normal distribution variable is z. So we use the notation z instead of x being any normal distribution with any mean or standard deviation. Z is this specific normal distribution with mean of 0, standard deviation of 1, and therefore any x can be converted into a z using this formula. So if you go x minus the mean of x divided by the standard deviation of x, then that x has been now converted into z. And what is the benefit of that? Why do we do that? And the reason why we do that is we can have one single normal probability table then, and then any x can be converted into the standard normal, and then we can use the standard normal probability table to find the probabilities. Okay. And this was the only way we could do probabilities if you go back some 10, 15, 20 years ago, because at that time only the table was available for probabilities. But now of course we have Excel, and you can simply type in the function in Excel and we can get probabilities, so we don't have to worry about tables. But we still need to learn the tables, because a lot of instances where you may not have access to Excel, you will have access to tables. Then you should know how to use the normal table as well as how to use Excel function. Okay. So once again, the standard normal distribution. So 0 is the mean, standard deviation is 1. So all z values below mean are negative values. All z values greater than its mean is positive values. So here is an example of how it is used. Suppose if x is a random variable that has a normal distribution, mean of 100, standard deviation of 50, these two are given. And suppose we want z value for x is 200 say, so you plug in x is 200, mean of 100, standard deviation of 50, then that x equal to 200 is converted to z equal to 2. In other words, x equal to 200 for mean of 100 and standard deviation of 50 is the same as z equal to 2. So here, so x equal to 200 is same as z equal to 2 if the mean is 100 and so on.